everyone, my name is Luiz Alberto. In this series of videos, I want to talk to you about solid principles. In this video, we will focus on the dependency inversion principle, which I consider one of the most important principles in solid. And even if you are a seasoned developer or you're just starting out, understanding it will make you a better developer. So let's get started. Okay, what exactly is the dependency inversion principle? In simple terms, DIP is all about decoupling software modules. This means making our code components less dependent on each other's concrete implementations, which leads to more maintainable and flexible software. Now let's understand first about some terms that we will use later in this presentation. The first one is about high-level modules. High-level modules are those parts of the system that implement the business rules or logic in our application. For example, the system component that coordinates tasks for an e-commerce application, such as processing orders or managing customer interactions. And low-level modules, on the other hand, are concerned with the details of how something is done. They are closer to the system's inputs and outputs, dealing with the implementation details. These modules are responsible for communicating with database, handling file system operations, sending messages over the network, and etc. For example, utility library that sends emails or handles HTTP requests. There are two key parts to remember. So, in the dependency inversion, it has 2 points. The first one, high-level modules, which provide business logic, should not depend on low-level modules, which implement basic operations. Both should depend on abstractions. And the second one is abstractions should not depend on details. Instead, the details should depend on abstractions. Why does this matter? By following DIP, you can ensure that changes to the low-level details of the system, like swapping out a database or changing the way emails are sent, have minimal impact on the high-level business rules and logic. This leads to a more maintainable, flexible, and decoupled system architecture. The problem with direct dependencies. Let's see a scenario, email notification system. Imagine we have an application that sends notification messages directly using a specific notification library. This direct dependency means if we ever want to switch libraries, we would face a significant challenge. Every part of our application that relies on this library would need to be identified, reviewed, and possibly rewritten to accommodate the new library's interface and functionalities across the application. This approach has several drawbacks. It makes our code hard to test, as it's tied to specific implementations. Changing or upgrading dependencies become a tedious process, and our code becomes less reusable and more fragile. Now, let's see how to apply the dependency inversion using PHP. So let's see the first example without using dependency inversion. In this example, the notification class is directly dependent on the email sender class. This makes the notification class harder to maintain and less flexible. For instance, if we decide to add another method of sending notifications, like SMS, we would need to modify the notification class directly. So you can see here in this code that we have an email sender class that has a send method with the logic here to send the message. And we have the notification class that is totally dependent of the email sender. For example, we are instancing the email sender here in the constructor to use it to send an email. So let's see here the right way using dependency inversion. So now we have the code refactored, and in this improved design, the notification class is no longer directly dependent on the email sender class. Instead, it depends on the message sender interface, an abstraction. This way, if we need to introduce another method of sending messages like SMS, we only need to create a new class that implements message sender interface and pass it to the notification class without changing its implementation. So here we have the interface, an abstraction, the message send interface that has only the method send, the email sender, there is a class that implements the interface, the message send interface, and it overrides the send method here and implement the logic to send the message. So in this case, the email sender class, it will send it by email. So we have another class, notification, that we will use the message send interface here as parameter in the constructor, and we'll call the send method on it when I call the send notification. So how to use it? Here we can see the email sender. We will instantiate just a new email sender. We will call the notification and we will instantiate it here, new notification, and we will pass to the constructor the way that we want to send this notification. In this case, we are passing the email sender. So here we can just call notification, send notification, passing the parameters, and if we need to change it, the way to send the notification, for example, an SMS, we will just need to change here, like we will say the way that we want to send the notification here when we instantiate the notification class. So just changing it here, it will change the way to send the notification from email to use SMS. Let's talk about some misconceptions. Deep is not just about using version control, containers, or dependency injection tools. It's a broader principle that guides the structure of your code, and it's not about eliminating dependencies but managing them through abstractions. You also can find dependency inversion at the heart of many popular frameworks and libraries. It's what allows them to be extended and customized for various needs. In microservices architecture, Deep helps in developing services that are loosely coupled, making the system more resilient and adaptable. And that's wrap on the dependency inversion principle. I encourage you to look at your projects through the Deep lens, experiment with it, and see how it transforms your code for the better. If you found this video helpful, please give it a thumbs up, share it with your fellow developers, and don't forget to subscribe for more code insights. Thank you for watching, and I will see you in the next video.